Good morning, students. We'll continue the topic nutrition, competition number 8.2, and today's subtopic is importance of proteins and quality of proteins in the diet. So here we are seeing the importance as well as various proteins and their qualities. Proteins are important constituents of tissues and cells of the body. Proteins are essential for growth, repair, and maintenance of good health. Protein forms important components of muscles, skin, and blood vessels along with other tissues. But these are the three tissues in which we will found large concentration of proteins. Apart from tissue, proteins also forms enzymes, hormones, and other vital metabolites of the body. Among the other functions of the proteins, they form antibodies which protect our body from foreign particles. Proteins are also important source of nitrogen for our body. Dietary proteins are essential source of amino acids for our body. Some energy is also provided by proteins. It is nearly about 10 to 15% of our total daily need of energy is coming from proteins in normal healthy adult. When enough carbohydrates are taken in the diet, the proteins are not utilized for energy. This is known as protein sparing effect of carbohydrates. If we take less carbohydrate diet, then the energy obtained from protein is more. During starvation, amino acids act as a source of energy. When excess proteins are broken down, there is increased excretion of urea in the urine. So end product of protein catabolism is urea, and it is excreted through the urine. Urea is formed in the liver and excreted through urine by filtering into the kidney. In importance of proteins, we should know about amino acids. If we study the nutritional classification of amino acids, three types of amino acids are there: essential amino acids, semi-essential amino acids, and non-essential amino acids. Essential amino acids means the amino acids which are not synthesized in the body, therefore they have to be supplied in the diet. There are 8 essential amino acids, the examples of which are valine, leucine, isoleucine, threonine, methionine, phenylalanine, tryptophan, and lysine. Now, semi-essential amino acids are synthesized in the body but not in sufficient quantity required in growing children and during pregnancy. So, they are called as semi-essential amino acids. There are 2 semi-essential amino acids, and the examples are arginine and histidine. The amino acids which are synthesized in the body are called as non-essential amino acids. Remaining 10 amino acids are non-essential for our body. Now, we will study deficiency of essential amino acids. If there is a diet which is deficient in essential amino acid, deficiency of one essential amino acid hampers the protein synthesis despite of presence of remaining essential amino acids, or all other amino acids are present. This limits the utilization of other amino acids for protein synthesis, and therefore all other amino acids, essential, non-essential, and semi-essential, are degraded and excreted in the form of urea. That means if one essential amino acid is deficient, then remaining amino acids are not utilized and they get degraded and excreted through the urea. So when the urea is excreted, urea contains nitrogen. So there is a loss of nitrogen from the body, and this leads to negative nitrogen balance. That is, more nitrogen is excreted than ingested. Sometimes in our body, non-essential amino acids are synthesized from essential amino acids. For example, cysteine and tyrosine are non-essential amino acids, but they are synthesized from methionine and phenylalanine respectively. Suppose if the requirement of these non-essential amino acid increases in the body due to any reason, then these non-essential amino acids are synthesized from essential amino acids, and it leads to the deficiency of essential amino acids. So this point you have to kept in mind. Now symptoms of essential amino acid deficiency. Symptoms of essential amino acid deficiency may be low appetite, vomiting, impairment in absorption, transport, storage of organic and inorganic nutrients, reduced synthesis of neurotransmitters, dull skin with fragile hairs, emotional disorders like moodiness, severe depression, anorexia, irritability, insomnia, anemia, etc. Now we will come to the protein requirement. ICMR expert committee suggests 1 gram per kg body weight of protein should be taken by Indian. This requirement is double for growing children, pregnant women and lactating mothers. Proteins are not stored in the body. If excess proteins are taken, then they are degraded and then excreted in the form of urea in the urine through kidney. Hence, intake of excess protein for a long period of time is harmful for the kidney. Protein requirement is also dependent on quality of proteins. Net nitrogen NPU means net protein utilization of protein of Indian diet varies from 50 to 60. Later on we will study what is NPU. So if NPU is low, the protein requirement is high and vice versa. Therefore, quality of protein along with quantity of protein in the diet is very, very important. NPU 50 to 60% means whatever proteins we are taking, all proteins are not utilized from the diet. The protein, the part of the protein or the portion of the protein which is utilized by the body is called as net protein utilization. This NPU varies from various types of food. Protein requirement and net protein utilization. Now, what is reference protein? The best quality of protein are the proteins which provide all essential amino acids in a pattern very close to the pattern of tissue proteins. Such proteins are called as reference proteins. For example, in our tissue proteins, all essential amino acids are not required in same quantity. Some essential amino acids are required in more quantity and others in less quantity. So the source of protein, that is food, should also provide the essential amino acid in that protein in a pattern close to the pattern of the tissue protein. Means the tissue, if a tissue requires X essential amino acid in more quantity, then that protein should also have X amino acid in more quantity. So that is the meaning. So examples of such reference proteins are egg protein, human milk protein, etc. Now coming to the nitrogen balance. Nitrogen balance can be measured by calculating dietary intake of protein nitrogen. In proteins, 16% by weight is of nitrogen, and then we will measure how much protein nitrogen is excreted daily. So nitrogen balance is calculated by formula I means dietary intake, is equal to U, that means loss of protein in the urine in the form of urea and creatine, plus loss of protein in feces and loss of protein through skin. So by this formula you can calculate the nitrogen balance. Two types of nitrogen balance are there. Negative nitrogen balance means when excretion of nitrogen exceeds intake, it is called as negative nitrogen balance. And positive nitrogen balance means when the intake of nitrogen exceeds the excretion, it is positive nitrogen balance. In this formula, I is equal to U plus F plus S. If the I is equal to, you will get some value. If that value is in positive, then it is positive nitrogen balance. If you will get I is equal to negative value, then it is nitrogen. Then it is negative nitrogen balance. That is, if I is more than U plus F plus S, then it is positive nitrogen balance. If I is less than U plus F plus S, then it is negative nitrogen balance. Simple. Now factors affecting nitrogen balance. First and most important factor which affect nitrogen balance is growth. Then hormone, pregnancy, coalescence, acute illness, chronic illness, and protein deficiency. We will study these factors one by one. Growth is a state of positive nitrogen balance. On an average, if person gains a weight of 5 kg, then his body will get 1 kg of proteins, and in that 1 kg of protein 160 gram of nitrogen is present. So he is in positive nitrogen balance of 160 gram if he gain a weight of 5 kg. Then some hormones causes positive nitrogen balance like growth hormone, insulin, androgen, and some hormones causes negative nitrogen balance like corticosteroids. Pregnancy is considered as a state of positive nitrogen balance because nitrogen is added in the fetus body. Next factor which affect nitrogen balance is coalescence. Coalescence means a state of a body after illness or after a surgery. So in this state, usually the person is in positive nitrogen balance because there is active regeneration of tissue is taking place in this state. But acute illness or surgery, stage of surgery, is considered as negative nitrogen balance due to loss of nitrogen during this stage. Also there is loss of nitrogen during trauma and burns. Chronic illnesses like malignancy, uncontrolled diabetes mellitus, and other debilitating diseases have negative nitrogen balance. Protein deficiency, even a deficiency of single amino acid can also cause negative nitrogen balance. Prolonged starvation is also causes negative nitrogen balance. To maintain the nitrogen balance, one has to satisfy the needs of nitrogen intake. Daily there is compulsory nitrogen loss through urine, feces and skin, and this account for about 3.5 grams of nitrogen for a 65 kg person, and this much nitrogen is present in 22 grams of proteins. Also during routine protein turnover, there is loss of nitrogen from the body. Protein turnover means daily the hormones, enzymes, neurotransmitters are synthesized, they perform their function, and after that they are broken down. Again new hormones, enzymes are synthesized and again they are broken down. So this is called as daily turnover of proteins. So during that daily turnover of proteins, there is loss of nitrogen due to breakdown of these enzymes, hormones and neurotransmitters. So minimum daily loss of nitrogen so protein is about 7.5 to 7.8 gram per kg body weight, and this should be supplied through the diet of good quality. So this much loss is always taking place through the body daily. Now after completing the importance of protein in the diet, we will see assessment of nutritive value of protein, means quality, how to assess the quality of proteins. There are several laboratory methods available for assessment of quality of proteins. Three are mentioned here. First is protein efficiency ratio, biological value and net protein utilization. Protein efficiency ratio. This is a very old test. In this test, feeding of 21-day rat with 10% test protein diet and recording the gain of weight after 4 weeks is measured or recorded. After that, protein efficiency ratio is represented by following formula: gain in weight in grams of that rat divided by protein ingested by that rat. So in this way the protein efficiency ratio is calculated. PER for some important proteins are given as: PER for egg protein is 4.5, PER for milk protein is 3 and PER for rice is 2.2. That means if egg protein is ingested, then the ratio of gain in body weight in grams by protein ingested in grams, that is not written here, is equal to 4.5. For milk protein it is 3.0 and for rice it is 2.2. So by this formula you can find out that egg protein is having better quality as compared to other proteins. Next is biological value of proteins. It is the ratio between the amount of nitrogen retained and amount of nitrogen absorbed during a specific interval. So biological value is equal to retained nitrogen divided by absorbed nitrogen into 100. Here BV is expressed in percentage, therefore we will multiply it by 100. Here one example is there. Protein A 127 mg is given to a rat. Out of this 127 mg of protein, 4 mg of protein it has excreted in stools and in 24 hours, and 24 mg of proteins it has excreted in urine. So protein absorbed by that rat is 127 minus 4 is 123, and out of this 123, 24 mg is excreted into the urine. Therefore protein retained in that rat is 99 mg, and BV is equal to 99 by 123. 123 is the absorbed proteins. So 99 by 123 into 100 is equal to 81%. So BV of that given protein A is 81%. Next parameter for estimation of quality of protein is net protein utilization, is equal to retained nitrogen by intake of nitrogen into 100. We will take again the same example where we have given 127 mg of protein A to a rat, which it has excreted 4 mg of protein in the stool in 24 hours and 24 mg of protein in the urine in 24 hours. The formula here is retained nitrogen by intake of nitrogen. So NP is equal to how much it has retained, 99. Again same, because out of 127 4 is excreted in stool and 24 mg is excreted in urine. So retained protein is 99, and how much is ingested, 127. So 99 by 127 into 100 is equal to 78%. So in the previous case the formula is retained nitrogen by absorbed nitrogen, but here the formula is retained nitrogen by nitrogen intake into 100, that is 78%. So NPU is better index than biological value to denote the nutritional quality and availability of protein. Next is concept of limiting amino acid. What is my limiting amino acid? Limiting amino acid is that amino acid which limits the weight gain when a protein is supplied to an animal. That means the amino acid which is not present in that particular protein, due to which the animal will not gain the weight. Certain proteins are deficient in one or more essential amino acids. If this particular protein is fed to a young rat as one of the source of protein, it fails to grow because essential amino acid is deficient in that protein. So here are the example of some proteins and their limiting amino acids. Rice and wheat, generally they are called as cereals. Limiting amino acid present in cereals is lysine. In gelatin, the limiting amino acid is tryptophan. Zein protein have tryptophan as well as lysine as two limiting amino acids. Tapioca have phenylalanine and tyrosine as a limiting amino acid. So phenylalanine is absent in tapioca. Therefore, this tapioca protein is given in patients of phenylketonuria. Then pulses are deficient in methionine amino acid. Now we will see chemical score. Some proteins contain all amino acids but not in sufficient quantity. Chemical score is based on biochemical analysis of protein for the composition of essential amino acid, which is then compared with the reference protein, usually egg protein. So definition of chemical score is defined as ratio between the quantity of most limiting amino acid in the test protein to the quantity of same amino acid in the egg protein, and it is also expressed in percentage. This chemical score is applied for essential amino acids. So formula is milligram of limiting amino acid per gram of test protein divided by milligram of same amino acid in the reference protein. Here reference protein, I have told you, it is a egg protein, and chemical score of egg protein is taken as 100. So by this formula we can find out the chemical score of various essential amino acids in different proteins. Here is the comparison of various proteins, biological value, net protein utilization, PER and chemical score. If you see here, in all respect the egg protein is at the top. Chemical score is considered as 4.5. Chemical score is considered as 100. PER is 4.5. So these are the comparison of various proteins. Now coming to a next important concept, which is called as mutual supplementation. If we see reference protein, which is egg protein, and the next protein is milk protein, then meats, all these are good quality of proteins, but they are very costly and it is not afforded by all people. Therefore, the concept of mutual supplementation is introduced. So, complete proteins are the proteins which are supply all essential amino acids in proper quantity to the body as per requirement. But complete proteins are costly. This problem is overcome by taking a mixture of proteins in the diet called as mutual supplementation of proteins. For example, pulses are deficient in methionine but rich in lysine. On the other hand, cereals are deficient in lysine but rich in methionine. Therefore, a combination of pulses plus cereal, that is chapati and dal, will cancel each other's deficiency and become equivalent to first class protein. The effect, or complete protein. The effect of mutual protein may be seen as weight gain in the animal. So if all essential amino acids are supplied to a animal, it will gain the weight. Now again the same chart that we have seen during limiting amino acid, but with mutual supplementation to overcome the deficiency. So first protein is rice protein. Rice protein is deficient in lysine. So to overcome this deficiency, we have to supply rice with pulses. Same with wheat, which is deficient in lysine. So to overcome this deficiency, we have to give pulses along with wheat to a animal. Gelatin, which is deficient in tryptophan amino acid, and that tryptophan is rich in milk. So milk should be given along with gelatin. Zein, which is deficient in tryptophan and lysine. For mutual supplementation, we should add meat protein along with zein so that deficiency of tryptophan and lysine will be overcome by meat proteins. Tapioca, deficient in phenylalanine and tyrosine, which can be overcome by fish proteins. Pulses are deficient in methionine amino acid, which can be overcome by giving cereal proteins with pulses. So in this way, the limiting amino acid deficiency can be overcome by mutual supplementation of various proteins in this combination. So in this graph, it is shown that in the first graph, if we give zein protein alone to animal, then the weight of that animal is decreased. If we add zein plus lysine to the food of that animal, again the weight is not maintained, it is decreased. If we add tryptophan plus zein to the food, again the weight is decreasing. But if we add zein plus tryptophan plus lysine in the food of that animal, then that animal will gain the weight. So what it suggests? That it suggests that zein is deficient in tryptophan and lysine, and if any one amino acid is deficient, then the animal will loses its weight. The same is shown in the second graph, where again zein alone will not able to maintain the weight, but lactalbumin will able to maintain the weight alone. But if we give lactalbumin plus zein, it will help to gain the weight of a animal. In the third graph, if we give cereals alone, then the animal will loses its weight, but pulses can able to maintain the weight. But if you give pulses and cereals both, then the weight of the animal is increased. So this is about the proteins and importance of proteins in the diet and the quality of protein. Thank you very much.